Given the shape of those graphs, which one or ones are continuous for all real numbers? I put the sketch above the Roman number.
What was the question?
Which ones are continuous? I'm looking at number 3. I sketched the graphs for you.
Oh. Second one. And the first one.
First and second?
Yep.
Everybody agree with that?
Yep.
The last time we had an all agree, then it ended up being wrong. So are we all agree?
Yes.
Okay, we still agree? Okay, so which answer choice is that?
C. I mean D.
D. D is correct. This was on an AP test. You see the asterisk, so that means it was on an AP test. If I recall, I think I actually created one more problem that wasn't on here, and I think I made up one for you to add to your notes so that we could practice figuring out if our function was continuous, similar to that one. Okay. Can I erase those sketches?
No. So.
Yes. Let's look at number 2, which also came from the AP test. It says, if the function f is continuous, and this is my function when x is not -2, then what should f of -2 be? Now, why do they do that like that and tell me it's the case when x is not -2? Because what happens when you put -2 in here? What do you get?
It's a no-no.
Do you get a no-no? Check the top. What do you get when you put a -2 in there?
4, 0, 0, 0.
So what does that mean?
More work.
Means more work. So that's why we couldn't let -2 be there, because right now there's a hole in that graph. I've got to figure out what the function value is that will plug in that hole. So how do we do the more work here? What do we need to do with that?
Factor.
Factor, very good. If we factor that, how does this factor?
X plus 2,
X plus 2, x
X minus 2.
minus 2, and what do we get?
X minus 2.
Now can you plug in a -2 into what's left?
Yeah.
That's the y value that will plug in the hole, and that's what you're looking for. That's the y value that will plug in the hole. That's what you're looking for.